Could lightning strike sauropods dead? Did they have trunks? How did they even reproduce? Reddit asked, paleontology answered. Let's get into it. How did lightning affect large sauropods? A 40-ton dreadnoughtus stands in an open Cretaceous floodplain. A thunderstorm rolls in, dark clouds, crackling air. And it's the tallest thing for miles. In the open floodplains of the Mesozoic, sauropods often outranked the conifers, ginkgos, and tree ferns around them. Lightning hunts tall, isolated targets. That's just physics. 300 million volts. 30,000 amps, enough to stop a heart and cook organs no matter how massive you are. Giraffes, our best modern analog for tall animals in open terrain, still get killed by strikes today for the exact same reason. Size doesn't save you when that much current hits your nervous system. But that remarkable neck might have actually helped sometimes. If a bolt struck the neck or back instead of the skull, the current had way more distance to travel before reaching vital organs like the heart and brain. Our sauropod might walk away, burned, scarred, maybe some nerve damage, but alive. Modern elephants and cattle sometimes survive strikes the same way. Across a long lifespan in the stormy Mesozoic, getting zapped was pretty much inevitable. Were large sauropod necks strong enough to counter the tornado winds? Or would they start helicoptering all over the place? Could a tornado lift a sauropod? Not a chance. A full-grown Argentinosaurus weighed as much as 10 elephants. But what happens to that enormous neck when an EF5 tornado comes calling? Sauropod necks were engineering marvels. Some stretched 15 meters long, supported by pneumatic vertebrae, bones hollowed out with air sacs, just like in modern birds. Add layers of muscle, plus cervical ribs working like tensioned cables along the sides, and you've got one of the most impressive biological structures that ever evolved. But that whole system was built for one predictable job: holding the neck up against gravity, pulling steadily downward, slow browsing movements. A tornado throws all of that out the window, winds over 322 kilometers per hour, hitting from constantly shifting directions, with wildly different speeds along the length of the neck. So while the body stays planted like a huge anchor, the neck gets thrashed around like a massive windsock. The muscles can't possibly keep up. It's not going to helicopter in circles. The neck is too flexible for that. Instead, the vertebrae get pushed past their range of motion. Ligaments tear. Cervical fractures follow within seconds. The same lightweight, air-filled design that lets sauropods grow those incredible necks in the first place is exactly what makes them vulnerable when the wind turns violent. What do you guys think about the idea sauropods had trunks? Back in the 1970s, a paleontologist looked at a diplodocus skull, noticed the nostrils sat weirdly high, almost on top of the head, and asked a wild question. What if sauropods had trunks? It wasn't a crazy idea. In modern animals, retracted nostrils often mean soft tissue up front. Elephants, tapirs, same skull pattern, and the hypothesis stuck around for decades. Sauropods with elephant faces had a real moment. But then paleontologists looked closer, specifically at Lawrence Whitmer's work on nasal anatomy. Turns out, the bony nostril and the fleshy nostril aren't always in the same place. The actual nose probably sat way forward, near the tip of the snout. And trunks need massive facial nerves to work. Elephants have huge nerve canals in their skulls. Sauropods, tiny ones. Plus, why would a sauropod even need a trunk? Elephants evolved them partly because their necks are short. Sauropods had long necks already doing that job. The selective pressure just isn't there. The current best guess? Not trunks, but fleshy, padded faces, probably with prehensile lips. Something closer to a moose or a black rhino than an elephant. Weird question, but could large sauropods even sit down? How did they lay eggs without them shattering into pieces? Picture a 60-ton patago titan trying to sit down. Legs like tree trunks, a belly the size of a school bus. Now picture it laying an egg. How does that work without disaster? Sauropods almost certainly couldn't sit the way we picture it. Their limb joints were built as columns, straight, weight-bearing pillars, not folding mechanisms. Bending those legs under 60 tons of body would risk joint damage or worse. Most paleontologists think adult sauropods spent their entire lives standing. Even sleeping probably happened on their feet, like modern elephants. So how do you lay an egg from 3 meters up without scrambling it on impact? The answer is in the fossil record. Sites like Mahuevo in Argentina preserve thousands of titanosaur nests. The eggs are surprisingly small, grapefruit-sized even from the biggest sauropods, with thick, shock-resistant shells. And the nests sit in shallow, scraped-out pits, sometimes in soft sand or volcanic ash. The leading idea: sauropods probably squatted partially, maybe bracing with their tails, and used a long oviduct to lower eggs gently into the pit, not a freefall. So, no dramatic sitting, just the quiet, practical biology of being the biggest parents Earth ever produced. Other than their immense size, what exactly did sauropods have going for them in terms of weaponry? Sauropods are usually pictured as gentle giants, walking mountains that just happen to be too big to eat. But strip away the size advantage, and what weapons did they actually have? Start with the most obvious, the tail. Diplodocids like Apatosaurus had whip-thin tail tips with over 80 vertebrae. Older biomechanical models suggested those tips could crack the sound barrier. Newer research pushes back, but even at just 100 kilometers per hour, a tail whip was still a brutal weapon, and the noise alone might have worked as a threat display. Then there's the wider defensive arsenal. Shunosaurus had a literal bone club on its tail tip, spiked even. Skin impressions from Diplodocus itself suggest keratinous spines running down the back. And don't sleep on the neck. Long, muscular, and capable of sweeping sideways with enormous force. Less a precision weapon, more a battering ram. Plus, sheer trampling. A 50-ton animal stepping on you ends the fight instantly. So, sauropods weren't unarmed. They were just armed like tanks. Overwhelming, blunt, and best avoided. Gentle giants, but gentle by choice. Which sauropod holotype is the most complete? Everyone knows Argentinosaurus. Here's the thing nobody tells you. We've found maybe a dozen bones. So which sauropod do we actually know well? There's a brutal rule in sauropod paleontology. The bigger the animal, the worse the fossil. Giants die in environments that scatter their bones. Patagotitan, multiple individuals, still no complete skeleton. Bryhathchaeosaurus? Basically rumors and a few eroded fragments. So the most complete sauropod holotype isn't a giant at all. It's Spinophorosaurus nigerensis, described in 2009 from Niger. Around 70 to 80% of the skeleton preserved, including skull material, which is almost unheard of for sauropods. A basal sauropod, mid-sized, middle Jurassic. For actual giants, Giraffatitan takes the crown. The Berlin specimen is the iconic museum mount you've probably seen photos of. Dreadnoughtus comes close with about 70% of bone types represented, but still no skull. The lesson? Fame and completeness almost never overlap in sauropod paleontology. The best-known ones are the ones nobody talks about. Were there any sauropod predators? Could a dinosaur like T-Rex have been a sauropod specialist? A full-grown sauropod was basically a walking fortress. So the question is, did anything actually hunt them? And could T-Rex have been a sauropod specialist? First answer on T-Rex: it's complicated. In the classic Hell Creek fauna of Montana and the Dakotas, there were no sauropods left. T-Rex hunted Triceratops and Edmontosaurus. But further south in what's now Texas and New Mexico, there was one giant sauropod still around, the Titanosaur alamosaurus. Fossil evidence, including a tyrannosaur tooth found with an Alamosaurus vertebra, suggests T-Rex did prey on it, at least occasionally. So not a sauropod specialist, but not totally sauropod-free either. But sauropod hunters definitely existed. In Jurassic North America, Allosaurus lived alongside Diplodocus, Apatosaurus, and Camarasaurus. And bite marks on sauropod bones prove they went after them. Later, in Cretaceous South America, Carcharodontosaurids like Giganotosaurus and Mapusaurus hunted titanosaurs like Argentinosaurus. Mapusaurus fossils have even been found in groups hinting at possible pack hunting, which you'd basically need to take down something that size. Nobody was killing a healthy adult titanosaur in a fair fight. The targets were juveniles, the sick, the old. And for the truly massive adults, probably ambush attacks aimed at legs and flanks. Slow bleeding, not clean kills. More hyena than lion. So yes, sauropods had predators, just not T-Rex. For that, you want the Carcharodontosaurs, the actual apex hunters of the Age of Giants. How did dinosaurs have sex? Two 40-ton sauropods. One wants to mate with the other. Nothing about this should work. So how did the biggest animals to ever walk the earth actually pull it off? The obvious issue? Weight. A male mounting a female, the standard tetrapod weight, means putting tons of force on her hips and spine. Early paleontologists took one look at the numbers and genuinely proposed sauropods must have mated in water, using buoyancy to take the load. That idea's mostly been abandoned. Sauropods weren't aquatic, but it shows how awkward the problem seemed. Modern thinking? It probably worked. Sauropod hips and tail bases were heavily reinforced, and their limb bones could handle enormous compression loads. Plus, the female's tail was flexible and likely shifted sideways during mating. Brief mounting, seconds, not minutes, would spread the stress. Some researchers have compared the mechanics to elephants or giraffes, just scaled up. Like modern birds and crocs, sauropods almost certainly had a cloaca, a single opening for reproduction and waste. We actually have one confirmed dinosaur cloaca, a 2021 fossil of Psittacosaurus that looks most similar to a crocodile's. Males probably had a retractable phallus concealed in the cloaca, similar to crocodilians. Phalluses themselves haven't been found fossilized, but phylogenetic bracketing makes it the safest bet. So, brief, careful, probably awkward, but functional. Evolution figured it out. Your turn. What's the weirdest dinosaur question you've ever had? Leave it below. The best ones make the next episode.